On December 24, 2024, a spacecraft about the size of a car did something we'd been told for decades was physically impossible. It flew into the sun. Not near it, not past it, into the outer atmosphere of a living star at 430,000 miles per hour, fast enough to reach the moon in about half an hour. The fastest thing human hands have ever built, pointed straight at the one thing in the solar system that could vaporize it. Then it went silent, and for days, no one on Earth knew whether it was still alive. It came back, but surviving the heat was never the point, because the strangest thing about that heat isn't how much there is, it's where it is. And to understand what this probe actually found, you first have to understand the one thing about the sun that still makes no sense. Move away from a fire and it gets colder. That isn't an opinion, it's one of the most dependable rules in all of physics. Heat spreads out from its source and thins as it travels. A campfire, a stove, a star. Step back and it fades. Everywhere except right here. The surface of the sun, the bright disk you can actually see, burns at about 10,000 degrees Fahrenheit. That alone is hotter than anything you will ever stand near. Now climb away from it. Rise up off that surface into the thin gas above, where everything you know says the temperature should fall. It doesn't fall. It climbs. Past 1 million degrees Fahrenheit. In places close to 2 million degrees Fahrenheit. The sun's outer atmosphere is hundreds of times hotter than the surface feeding it. That outer atmosphere has a name, the corona. It's that ghostly ring of light, the crown that flares around the sun the instant the moon blocks it out, the one millions of people just crossed the world to stand under. The air above the fire is not cooler than the fire. It is 200 times hotter. 200 times. The nearest star, breaking one of the oldest rules in physics, and getting away with it. Physicists have known about this since the 1940s, and they gave it a name that sounds almost polite: the coronal heating problem. Something up there is dumping enormous energy into that thin gas, and for 80 years, no one has been able to say what. 80 years. The one star our whole world runs on, and we still can't explain its own atmosphere. So we decided to stop watching from a distance. But you cannot put the sun's atmosphere in a jar. Nowhere on Earth can you build a place millions of degrees and near vacuum at once. The only place those conditions exist is the sun itself. So if we wanted the answer, we had to go and read it straight off the star. The sun's atmosphere, the corona, reaches millions of miles out into space. And there's a line out there, invisible, that scientists call the point where the sun lets go. The boundary where the sun's grip finally loosens and its atmosphere breaks away as the solar wind. Cross that line, and you are no longer near the sun. You are, by any honest definition, inside it. In 2018, we launched a probe built for exactly one purpose: to cross that line and survive. Its shield is 4.5 inches of carbon, built to take nearly 2,500 degrees Fahrenheit head-on, hot enough to melt steel, while the instruments inches behind it sit at room temperature. And it has to hold that shield dead on the sun, completely alone. Slip more than a few degrees, and the instruments behind it are gone in seconds. It held its aim every single time. So far. The first time any craft ever crossed that line was April 28, 2021, the moment NASA said that, for the first time in history, we had touched the sun. And then it kept going back, deeper on every orbit, until on Christmas Eve of 2024, it fell further in than it, or anything else, ever had. Then it slipped behind the sun out of contact, and the team could do nothing but wait for a single beacon tone to tell them it was alive. The tone came. The probe held. The engineering worked so well, it almost made the hard part look easy. But the hard part was never the fire. It was what the probe was seeing while it flew through it. On August 12, 2026, that same crown blazed out over Greenland, Iceland, and the north of Spain. The first total eclipse to cross Spain in more than 100 years. People flew in from as far as the United States and Japan. Hotels had been booked solid for months. And when the sun went out, there was cheering, applause, people in tears. That night, the same new moon left the sky dark for the Perseids, 100 shooting stars an hour, 2 shows in one day. But the thing millions had crossed the world for was those 2 minutes of ghostly crown, the most beautiful thing in the sky, and the single least understood. And even a flawless eclipse only ever gave us that. 2 minutes, once in a rare while, from 93 million miles away. The best look we'd ever had. Parker doesn't wait for the moon. It flies straight in. And it stays. Now we had a camera inside the corona itself. Its name is Whisper, riding on the sun-facing edge, staring into the corona as the probe tore through it. And the closest images ever taken of a star showed something the textbooks had quietly smoothed over. Up close, the corona isn't a calm, glowing shell at all. It's violent, knotted, streaming, tearing itself apart and reforming in real time. We'd drawn it as a soft blur, all our distance ever let us see. From the inside, it looked like weather, the most violent weather in the solar system. And somewhere in that chaos was the thing the probe had come to catch. The exact moment the sun's atmosphere stops being the sun and starts becoming the wind. Every second, the sun blows about 1 million tons of itself out into space. This is the solar wind, a constant gale of charged particles that washes over every planet, including ours. It is also one of the hardest things in space we have ever tried to predict, because when it turns violent, our world is the first thing it breaks over. We've known it exists since the 1960s, but never where it gets its speed. Something flings it outward at over 1 million miles an hour, and that close in, the mechanism stayed hidden. The probe flew straight into the region where that acceleration happens, and found the wind wasn't flowing the way anyone had drawn it. Instead of a smooth outward stream, it hit sudden, violent kinks in the sun's magnetic field. Places where the field bent back on itself in a hard S shape, then snapped forward again. They called them switchbacks, and they weren't rare. The closer the probe got, the more of them there were. Each one is a whip crack in the magnetic field, and they appear to be part of how energy is transferred into the fast solar wind. For the first time, we weren't theorizing about how the solar wind is born. We were flying through the room where it happens. But the deeper the probe went, the less the sun behaved like a machine we understood. To see why that mattered, you have to go back to 1958. A physicist named Eugene Parker did the math on the space around the sun and came to a conclusion almost everyone thought was absurd. Space near the sun, he said, isn't empty. It's a gale. A supersonic wind of charged particles blasting outward all the time. The reaction was brutal. Reviewers tried to kill the paper. Senior scientists told him flatly that he was wrong. 4 years later, a spacecraft crossed the space between the planets and found exactly the storm Parker said would be there. He'd been right the whole time. That's why, 60 years on, NASA named its sun-diving probe after him. the first time it ever named a mission after a living scientist. And that probe flew straight into the question he never finished. Because we still don't know what heats the corona. We've narrowed it to two suspects. One, countless tiny magnetic explosions going off across the sun like a billion camera flashes, each one dumping heat into the gas above. Two, magnetic waves rippling up from below and shaking themselves apart in the corona, spilling their energy as heat. The switchbacks the probe flew through are evidence in that fight. Proof the magnetic field up there is far more violent than we ever drew it. But a clue isn't a verdict. Two suspects, both still standing. And our one eyewitness keeps diving back in for another look. Sometimes the sun doesn't just leak. It erupts. A coronal mass ejection is 1 billion tons of magnetized plasma thrown off the sun in a single blast, moving at millions of miles an hour. 1 billion tons, more than the combined weight of every human being alive on Earth, fired off the sun in a matter of hours. Aimed at Earth, one of these can take down the power grid across entire regions. And extreme space weather isn't a question of whether it will return. The only question is when. We'd tracked them for decades, but always from far off, after they'd thinned out. This time, the probe flew near them while they were still forming. And on this pass, it caught something no instrument had ever resolved this close. Separate eruptions, colliding and merging in real time as they climbed away from the sun. Not one clean storm. Storms crashing into storms, right at the source. This is what the corona really is. Not the calm halo we drew from a distance, but a magnetic battlefield violent enough to smash its own eruptions together. And a merged storm is even harder to predict than the two it came from. And prediction is the whole game when the target is us. Here's the part that's easy to miss, and it may be the strangest of all. Not everything the sun throws off actually escapes. In the wake of one eruption, the probe watched material that had just been flung outward stop, turn, and start falling back toward the sun it had left. We'd caught hints of this from a distance. Parker was the first to watch it happen up close. The magnetic field lines had stretched, snapped, reconnected, and hauled part of the plasma home again. Picture a river that, in places, decides to run uphill. The sun's atmosphere isn't a one-way exhaust. It's a churning boundary where matter is constantly deciding whether it even gets to leave. Every one of these findings, the violent corona, the switchbacks, the colliding storms, the matter that turns back, was supposed to add up to the answer: why that thin gas runs 200 times hotter than the surface below it. The probe didn't stop after the record dive. It's still out there, still looping in, diving back to that same record distance again and again, catching the sun in a different mood each time. And on one of those loops, it did something no one had designed it for. A visitor from beyond our solar system, an interstellar object we call 3I Atlas, came through the inner system. For a while it was invisible from Earth, too close to the sun, lost in the glare of the daytime sky. But Parker had something Earth didn't: a clear line of sight. While the sun's glare hid the interstellar traveler from us, Whisper was still able to watch it. A machine built to study our own star, briefly turned into a witness for a piece of another one. But Parker's real unfinished business was still waiting back at the sun, the one thing all those dives still couldn't give us. The coronal heating problem is still unsolved. But the probe didn't come back empty. It came back bigger. Before Parker, the mystery was a smooth, distant halo. Now, it's a violent, structured machine, and we can watch the gears turn without understanding what drives them. That isn't failure. It's the moment right before an answer. And this stopped being abstract the moment you switched on a device this morning. In March of 1989, a single storm off the sun slammed into Earth's magnetic field and dropped the entire power grid of Quebec in 90 seconds. 6 million people. No power. In the dead of a Canadian winter. And Quebec wasn't the only grid in trouble. Across the northeastern United States, power systems came dangerously close to a cascading collapse. That storm came from exactly the kind of place this probe is now flying through. And the same storms still come. Into a world that now runs on the grids, the satellites, and the power in the room you're sitting in right now. The sun isn't finished with us. On August 2nd, 2027, another total eclipse crosses southern Spain and North Africa. And this one doesn't stop at 2 minutes. Near Luxor, in Egypt, the sky goes black for 6 minutes and 23 seconds, almost 3 times longer than 2026. That same crown will blaze out again, that same impossible heat. And we still won't be able to tell you what makes it burn. There is more to explore. See you beyond the stars.